Good evening, everyone. So, every once in a while, a new technology, an old problem, and a big idea turn into an innovation. So, with these words about innovation and creativity, I would like to welcome our esteemed guest and the audience to the third virtual exhibition of Kshitij Planned for You. And we will be also having a Q&A session at the end of this session. So I request the audience to please put their questions in the chat box. So without any further ado, I invite Mr. Tim to take over the session. Tim?
So, hello, I will share my presentation.
Yeah, sure.
Can you all see the screen, the presentation, the slides? I hope so. So I will start. Thank you for the introduction. So yes, I'm from Project March, the Netherlands. And who am I? I am Tim de Moy, the public relations coordinator of this year. And I will tell a bit about myself. I'm still a student. I studied here in Delft, the Netherlands, a small city in the Netherlands. Um, I studied so-called clinical technology, which entails that I study most of the technologies around healthcare. So MRI scanners, CT scanners, and a lot of other stuff. And you will see in the coming half an hour, 3/4 of an hour, that Project March is a very nice addition to this study. And you will probably understand why I choose to do a year of Project March. So then comes the question of what is Project March? Project March is a so-called dream team. I will explain later what it entails, but we are building an exoskeleton. You see the exoskeleton of last year on your screen. You can also see it behind me. Yeah, the left side. Um, Here, and this an older version of the exoskeleton. But an exoskeleton enables someone with a spinal cord injury or who is paraplegic to stand up and to walk again. So the exoskeleton takes over all the functions of the legs because someone with a spinal cord injury or who has paraplegia is not able to stand up and use his muscles, feel his legs because his spinal cord is injured, is broken. So the signals from his nerves in his legs don't come up to his brain, and the signals from his brain to the muscles don't go down. So he can't move his legs. He is always wheelchair bound. But with this exoskeleton, he is able to move around, to use his hands again, and to stand up, actually. So, of course, this picture is nice, but how does it look in the video? And the videos on the next slide will explain a bit further what we do as Project March.
We are Project March. By building an exoskeleton, we make a positive impact on the quality of life of people with a spinal cord injury. An exoskeleton enables them to stand up and walk again. This comes with great benefits for the mental and physical health. Every year, a new multidisciplinary team of young, enthusiastic students take up this challenge. Since 2015, we have been pushing the boundaries of exoskeleton technology. We do this in close collaboration with the user, our partners, and the March community. Together, we create more awareness around exoskeleton technology. Together, we can make an impact. Together, we are Project March.
So as was told before and also in the video, is our vision is to improve the quality of life for people with a spinal cord injury by pushing exoskeleton technology. So what does this entail is that, of course, we are making an exoskeleton and we try to do our best, but our goal is not to make it commercially and to give it to a lot of people, but our goal is to pushing exoskeleton technology. So to push the market to make a really feasible exoskeleton that can be implemented in daily life and can be implemented to a lot of people that have the problem of spinal cord injury. We are just a student team, so that's not in our reach. But we try to do our best to push the market, to push commercial parties to make this technology feasible and affordable for a lot of people. So how do we test our exoskeleton? We actually have someone who is wheelchair bound for all of his life, who has spinal cord injury, and we call him the pilot. So the one who is controlling the exoskeleton, who is walking in it, is called the pilot. And for our year and for the last 2 years, this was Koen van Zeeland. You see him on the left part of your screen. And we always get our pilots from a rehabilitation clinic, the St. Maarten's Clinic. That's a rehabilitation clinic, one of the big 7 rehabilitation clinics in the Netherlands. And they provide us with the pilot. There are certain standards for our pilot. We need them to have certain standards. One is that the spinal cord injury needs to be between a certain level. It can't be too high because then you lose too much function. You can lose function in your arms or function in your muscles in your back or your belly. That's not very handy. And the spinal cord injury can't be too low because then you maybe still have some function in your legs, and this will interfere with the motors in the exoskeleton. And this is not allowed by a competition we participate in once every 4 years. That I will explain later again. But then what is a spinal cord injury? What is paraplegia? Paraplegia is something I'm not sure actually about that. But after March 5, COVID hits, so we are all bound to work at home, work on ourselves and not in one group at one place. So our goal shifted a bit from winning the Cyberlon or winning the competition to actually going outside, because the competition, the Cyberlon, is very set part of rules. It's always inside, clean floor, it's very flat, that kind of stuff. But when you go outside, you have some bumps, walk on some grass or some bumpy roads. And that was the new goal of March 6 and actually March 7. But how does the March 7 actually look, and what have we already achieved in the past 7 years? For that, I have a design video of last year, which I will show you. So I will pause it here and explain a bit more about what they actually did as March 7. So this is the exoskeleton, at least this was the design of the exoskeleton of last year's team. And as I told, we started in March 1 with only 2 joints and a very stripped down version of an exoskeleton. But as you see on your screen, we now have a way more advanced and versatile exoskeleton. We actually now have 4 joints per leg. So still one in the knee, of course, one in the hip, of course, one in the ankle to move your foot like we all can, and one in the hip to move the leg in the lateral direction. So it's in the medical field, it's called abduction and adduction, to move your leg like in this way, in this swinging way. And last year they focused on 2 big things, which is the dynamic walking and an EEG part, which is brain control. I will first explain the dynamic walking. This entails that the exoskeleton before March 7 was always programmed to do a certain step. It always followed that program and didn't matter what the underground or the surroundings were. It always followed that certain step, length step, the way to take a step, the certain gait. That's what we call it. And March 7 implemented dynamic walking, which entails that the exoskeleton is every second or every 10 times a second is calculating what is the best possible step to take to reach my goal. So we tell the exoskeleton go 5 meters to the front, then the exoskeleton is going to calculate what the right step length is, how fast it needs to walk, what is the most optimal way to walk that 5 meters. Of course, on a flat surface, this is not really big of an issue, but if you think about it for some set of stairs, actually achieved to control the exoskeleton with the brain. So we put up a thing on his head, and which measured the brain waves of the pilot. If the pilot thought about walking the same way as we do, so not walking, but the same way as us. So what happens in our brain if we start walking? If the same thing happens in the pilot's, his brain, the exoskeleton actually starts walking. So that is an enormous step in his self, in his ability to rescue himself if he falls or if he wants to go for a walk. That's an amazing step. Not again, that's a bit too much. So that was March 7, but I am for March 8. Here you see my team. We are with 26 amazing students, multidisciplinary students. We are all in a different, or we studied some different backgrounds like mechanical engineering, industrial design, clinical technology, electrical engineering, mathematic engineering, all kind of different stuff. Even architecture, different word, difficult word. But we are the new team and we are developing the March 8 exoskeleton. Here you see March 7 and March 6, and we are developing March 8. We started in September, so we are not done yet. We are busy in the embedded stage. So we are working out our concepts and trying to make those work together. So how is the March 8 team structured? We have a management. These are all students, only students. No, we have no external guidance. So management team, which has we have a project manager, an operations manager, a chief engineer, and of course a team manager, which is like the directory board of our team. Then we have an operations department, which is we always walk with crutches in our hands. You will see it in a video I will show later from March 7. but we were always walking with crutches, and this meant that the walking pattern was not like we used to walk. So it was not a natural walking pattern. So for this year, we try to throw away the crutches and walk self-balanced. Yeah, we are from the TU Delft in the Dream Hall, and that means that we are a so-called dream team, like I explained some times ago. And a dream team entails that we are a student team. So a team completely consisting of students, and those students have a yearly cycle. Our student year is from the beginning of September till the end of June, and we have the same cycle. So every new study year, there's coming a new team, completely new team of students in and out. So at the end of my year, I will move on with my studies, and another team will take over our job and complete the next exoskeleton, the March 9. Being a TU Delft Dream Team also entails that we are all full-time working on this project. So we are with 26 students who are all stopping their studies for 1 year to work on this project full-time, and most of the weeks even more. So some weeks we are working 60, 70 hours, enjoying our student life, drinking with friends, partying, do some sports. So it's a busy life, but nevertheless, it's really fun. In the Dream Hall, there are 4 other dream teams. It's the Delft Hyperloop team. They are creating an Hyperloop system, which is a really fast train in a vacuum tube. You can move, I think 1,000 kilometers an hour, so as fast as a plane, but then over land. We have a Hydromotion team, which is a boat powered by hydrogen. So it's a very eco-friendly boat at the moment, and they are competing in the Monaco Open Sea class, which is the kind of World Cup for this kind of boats, and they are like almost winning every year that cup. The third team is the Eco Runner Team Delft. They are building a very efficient hydrogen car, so it's also powered by hydrogen. And on 1 kilo or 1 liter, 1 kilo, I think, of hydrogen, they can drive almost 4,000 kilometers. So that's from the Delft, the Netherlands, to the south of Spain and back. And that's, yeah, it's a really long distance. Of course, they take a lot of time for that. They're not really fast, but they are really efficient. And it's actually a city car. It doesn't look anything like a city car, but it is officially a city car. So it has lights, it has upright sitting position, it has number plates. It is officially a city car. And then the fourth team is the Epoch Team Delft, which is in artificial intelligence. It's really vague what they're doing for all of us in the Dream Hall, but they are competing in multiple challenges a year, and every challenge is taking 3 months. So every 3 months they have actually new kind of goal. Last challenge was about the efficiency of solar panels. They are also doing something with the algorithm behind Wikipedia. They have some really amazing projects, and where all the other dream teams do 1 project a year, they do 4. So that's very nice for them. And as I said, we are competing in the Cyberlon, and Project March is competing in the Cyberlon. The other dream teams are competing in their own kind of competition. But the Cyberlon for Project March is is Bionic Games. It's what it's called, and you have 6 categories. So we are competing in the 5th. It's the powered exoskeleton race. You see it here. This is one of our competitors. But you also have a powered arm prosthesis, a powered wheelchair, and even on the left, a brain control competition. So that they are a loss of bladder and bowel function. That's something that people in a wheelchair have a lot of problems with. So we're helping with that a bit. Of course, a loss of touch sensation is not something we can improve because the nerves are broken. But one of the most important things that we improve with an exoskeleton is the psychological function of people, the psychological way they think. Because you can imagine, if you're always in a wheelchair, you're always on a lower side of the world. You're always looking up to people. If they're having a drink, they're always looking down onto you, and that could be really hard for you mentally. So if they could stand up sometimes, could have a drink on eye level, could see someone in the eyes at the same level, it's a really big step for them, for mentally. And that's actually the biggest benefit of an exoskeleton, and not the ability to move again. So something we need to look out for is decubitus, or pressure sores, because people with paraplegia or spinal cord injury can't feel anything in their legs. And if you put some pressure on your skin, we can feel that it's not comfortable, and after 5 minutes it starts to itch a bit, and so we remove the pressure if possible. People with a spinal cord injury can't, or they can remove, but they can feel that there is some pressure on their leg or their skin. So if we don't look out for this, they will get some pressure sores, which entails that the skin is broken, and if it's really really long, you can get like a wound you see in the picture 4, which needs a half year to heal. So that's really bad for us. um, so we do not train for more than half an hour in one time. Then we remove them for the exoskeleton, let them feel a bit free, let them ride around in their wheelchair a bit, so their skin could heal a bit, could re needs a half year.
Together, we
Maybe still have some function. We tell the exoskeleton, go. So how is the March 8 team?